Hi, and welcome to Maths with Kirin. We are up to lesson 7, so today is all about solving exponential equations and inequalities as they sometimes come up in your exam as well. So we're just going to get straight to it. So an exponential equation is an equation when a number is raised to a power. So typically we write it as b to the power of x is equal to y. So b is a b because we refer to this as the base number. X in this particular way of writing it is your power, and y is what it is equal to. So typically the unknown part of the expression is the power, is the x that you're solving for, but you may come across a question where the unknown is the base, and you're trying to figure out what that is. So we will look at both. To solve an exponential equation, we substitute values into the unknown, and as you'll see when we go through some of the examples, we use some of the other algebra techniques that we have covered in some of our previous lessons. So there are sometimes end up with quadratic equations to solve or linear equations to solve in order to get the answer for the exponential equation. Okay, so one thing to note, if the base is the unknown, that's the thing that you're solving for, and the power is an even number, then there are two solutions. Okay, and that's because if we think of the example x squared is equal to 16, x is in the base, so we're solving to the base, and 2 is an even number, then we already know that there are two solutions to this, positive 4 and negative 4. So if you see something written like this with this sort of plus minus out in front, that means that we're talking about two numbers, positive 4 and negative 4 in this particular case. And likewise, if you had x to the power of 4 equals a particular number, then again you would still have those two solutions, okay? Because if you have a negative and you're multiplying it by itself an even number of times, you still get a positive solution, okay? So that's just something to note. So we've got some examples to go through, different degrees of difficulty, and then we'll talk about what happens if we have an equation. So for this first example, we've got 3 to the power of x is equal to 81, so we need to multiply 3 by itself a number of times until we get to 81. All right, so if we sort of just think 3 times 3 is 9, 9 times 3 is 27, and 27 times 3 is 81. So therefore x has to be 4 because we've got 4 3's multiplying together to get 81. The other way you might think of this, 81 is 9 times 9, and you can create 9 by multiplying 3 by itself. So 3 times 3 is 9, 3 times 3 is 9, and then 9 times 9 is 81. Okay, so whatever way works for you, but we get x is equal to 4 for that first example. For the second example, we've got 6 to the power of x plus 1 is equal to 36. Now we know that x squared is equal to 36. So that means that x plus 1 must be equal to 2. Okay, in order to get that 6 to the power of 2, we know that this must be equal to 2, in which case we've now got a linear equation. So moving our 1, isolating our x, we get x is equal to 1. That makes sense. 1 plus 1 is 2. 6 to the power of 2 is where our 36 comes from. Okay. Question 3, we've got 4 to the power of x plus 7 is equal to 23. So like a linear equation, we want to isolate the 4 to the power of x, and then we can use the exponential techniques in order to solve x. So we move our 7 across first, and 23 minus 7 is 16, and 4 squared is 16. So x must be equal to 2. Okay, and the fourth example, x to the power of 3 is equal to 125. So this is a case where our base is the unknown. So we need to think of a number that we can multiply 3 times by itself in order to get to 125. So if you do a few as practice, you'll kind of get a better feel for where you might start if you don't know what the answer is off the top of your head. And we already know from here that 3 times 3 times 3 is 27. So 3 is too low. We could try 4. So 4 times 4 is 16. And then if we multiply 16 by 4, we get 4 times 10, which is 40, plus 4 times 6, which is 24. So that would give us 64. So that's too low. 5 times 5 times 5 would be the next logical choice. So 5 times 5 is 25. And if we multiply 25 by 5, we get 125. So x must be equal to 5, because 5 cubed is 125. It can't be negative 5, because negative 5 cubed would be negative 125. So in this case, it's an odd number, so we only have x is equal to 5 without any solution. Okay. Oops. There is one more example. I've just moved 2 pages, sorry. So this one is a bit more tricky, a little bit more difficult. We've got 4 to the power of x minus 1 is equal to 2 to the power of 3x plus 1. So what we actually want to do is rewrite this. Because these bases are different, we can't really do anything with our powers. But if we can get the bases the same, so this 4 to be a 2, then we've got the same base on both sides of the equal sign. And if those two things are equal, then our powers would therefore have to be equal, and we can create an equation and solve it. So can we rewrite 4 so that it's 2 to the power of something? And if we can do that, then that will simplify the solving of this particular equation. So 4 can be written as 2 squared. So instead of writing 4, we're going to replace that with 2 squared. That's still to the power of x minus 1, and we haven't done anything to that right-hand side. So all we've done is rewrite 4 as 2 squared. Okay, now we know using our other algebra rules that if we have a power to a power, we multiply those powers together. So we're going to create 1 power by multiplying that 2 by x minus 1. So our 2 is still the base. 2 times x is 2x, and 2 times negative 1 is negative 2. Remember, we're multiplying 2 by all of x minus 1, so we get 2x minus 2. And our right-hand side is still the same. Now we've got 2 as the base on both sides. So if 2 to the power of 2x minus 2 is the same as 2 to the power of 3x plus 1, then 2x minus 2 has to be the same as 3x plus 1. It's the only way that those two things are the same. So from here, we've got a linear equation, so we can solve it. Bringing our 3x across, 2x minus 3x is negative x. And bringing our negative 2 to the right-hand side, 1 plus 2 is 3. So if negative x is 3, then positive x have to be negative 3. Okay. Hopefully that makes sense. If you wanted, you could substitute back in here and make sure that it works. Okay, that you get the same thing, but that's how we can solve that. So moving on to inequalities, we solve them in much the same way. It's expected at level 1 that you only need to find whole number solutions, so you don't need to be trying to find a whole lot of decimal places. If you do take level 2 maths at some stage and you do the algebra paper, then you will use logarithms in order to solve exponential equations exactly. But at level 1, you should only be dealing with whole number solutions. Okay, so we're going to use a little bit of substitution to try and find out what our answers would need to be so that we can satisfy the inequality. Okay, so as always, if we're going to multiply or divide the whole expression through by a negative number, we need to make sure that we reverse that inequality. And we saw that with linear inequations, but also with the quadratic inequations in that last lesson that we did on Monday. So these two examples here, we're wanting to find whole numbers that satisfy the inequation. So we've got 2 to the power of x needs to be greater than 10. Okay, so 2 times 2 is 4, times 2 is 8. So that gives us 8. If we have 2 to the power of 4, we get 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, now we want 2 to the power of x to be greater than 10. So we know that 2 to the power of 3 is 8, and 2 to the power of 4 is 16. So that means that x has to be greater than 3 or x has to be greater than or equal to 4 because we're only dealing with whole numbers. 3 itself isn't good enough because it only gets us to 8. We need to be greater than 10. So x is greater than or equal to 4, or you could write that x is greater than 3. The second example here, we've got 3 to the power of 4x minus 6 needs to be less than 8. So the first thing we want to do is figure out 3 to the power of what would give us something less than 8, and then we can deal with the 4x minus 6. So 3 squared is equal to 9. We know that. So that means that 4x minus 6 needs to be less than 2. Okay, because if it is 2, then we're too high. 9 is obviously higher than 8. This is telling us we need to be less than 8. So if that has to be less than 2, then 4x needs to be less than 8, which means x needs to be less than 8 divided by 4, which is 2. So x has to be less than 2, which means it could be 4x is less than or equal to 1. Okay. Either of those is fine. Cool. So we're going to jump straight into some exam questions. So we'll start with one from the 2019 paper. I think I'm reasonably confident that this was actually the only question from the 2019 paper that involved an exponential equation. You might remember we had quite a few linear equations from that 2019 paper, not so many exponential ones. In 2018, we didn't have many linear equations to solve, but they had a few more exponential ones. So who knows what will happen? Best to be prepared for both. So this is quite a tricky one. We want to find the values of x if 36 times 6 to the power of 2x plus 6 is equal to 6 to the power of x squared. So we've got a lot going on here. You'll notice perhaps first of all that we've got 6 and 6 as a base here, and we've got 36 here. So it might be a bit of a clue that we really want to try and rewrite this so that we've got 6 as a base, because if we can do that, then we can use some of our algebra skills to simplify this left-hand side. Okay, so 36 is actually the same as 6 squared. So we're going to rewrite that. 6 squared times 6 to the 2x plus 6 is equal to 6 to the power of x squared. Now here we've got 6 squared times 6 to the power of 2x plus 6. You might remember in algebra, if you have an x squared times an x to the power of 4, for example, we add those powers together. So that would give us x to the power of 6. Likewise, if you had 6 squared times 6 to the power of 4, you would get 6 to the power of 6. Because this is 2 6's multiplying together, and this is 4 6's multiplying together. And if you multiply 2 6's by 4 6's, you get 6 6's multiplying together. So that same rule applies here. We're adding our powers. So because we have the same base, and that's why we needed to rewrite this with a base of 6, we can add our powers together. So we're going to simplify this left-hand side. We still have 6 as our base, but we get 2x plus 6 plus 2, which is 2x plus 8, is equal to 6 to the power of x squared. Okay, and now, again, we've got the same base. So if these two things are equal, then 2x plus 8 must be the same as x squared. Hopefully you recognize this as a quadratic equation. So we have a quadratic to solve. We want to move all of our terms to the left-hand side. So if we bring our x squared across, we get negative x squared plus 2x plus 8 is equal to 0. To solve a quadratic, we then need to factorize. A little bit more difficult if you have a negative x squared. So you might like to multiply everything through by negative 1 to give us x squared minus 2x minus 8 equals 0. And then we can factorize from here. Negative 8 means we have a negative and a positive number. We want them to have a difference of 2. So that would be 4 and 2. And we want negative 2x, so we need negative 4 plus 2, which means we actually have two solutions. X is equal to 4 or negative 2. Okay. So for this question, to get achieved, you can do one of the following. You can rewrite 36 as 6 squared. Okay, that's it. You rewrite 36 as 6 squared, you can get achieved. Or you might not specifically rewrite that, but you might get 6 to the power of 2x plus 8 that would give you achieved. If you consistently generate a quadratic equation from your powers, so say you made a mistake here, maybe you multiplied and you got 4x plus 12 is equal to x squared, and you could generate your quadratic equation from that, then you can get achieved. For merit, you consistently solve your quadratic equation. So if something happened, you made a mistake up here somewhere and you didn't quite end up with this quadratic equation, but you consistently solve your quadratic equation, then you get merit. And for excellence, you get the correct solution. Okay, so you work your way through and get both x is equal to 4 and negative 2. So moving on to a 2018 question. We want to find the value of x if 3 to the power of x plus 1 is equal to 81. So not quite as difficult as the question we just went through, a bit more straightforward. So 3 to the power of x plus 1 is equal to 81. We know from before, 3 times 3 is 9, and if we multiply by another 9, we get 81. So 3 to the power of 4 is equal to 81. So if we want this power to be equal to 4, x plus 1 is equal to 4, which means x would have to be 3. Some of you might know that just by looking at this. What I suggest you do is still write out some working. You don't necessarily need this line, but it would be good to see 3 to the power of 4 is equal to 81, which means x plus 1 is equal to 4, which means x is equal to 3, because you want to show that you're not just doing some sort of guess and check, that you are using some algebraic procedures in order to get to the solution. For this question, it's an achievable question, so you need to get all the way through to get achieved for this one. But for example, if you did guess and check for this question, then the highest grade you could get would be achieved. So you want to be able to show that you've got some algebraic working in order to get those full marks. Okay, so that's just achieved for that question. There is no alternative answer. You can solve it using guess and check methods, but just, I guess, get into the habit of trying to write out some of that algebraic working so that you don't inadvertently miss out on some higher grades in some of these questions. Okay, so third exam question, this one from the 2018 paper. So looks kind of similar to the 2019 question, except this one is an inequality. Okay, but otherwise we've got 8 times 2 to the power of x minus 4 is less than 20. So again, you could divide through by 8 and solve it. It just gets, I guess, some people find it a little bit more difficult because 20 doesn't divide by 8 very nicely. So it might be tidier, perhaps, to think about rewriting 8 with 2 as a base, which we can do. 2 times 2 is 4, times 2 is 8. So instead of writing 8, we can write 2 cubed times 2 to the power of x minus 4 is less than 20. And then we can use that same algebra rule we used before, because we're multiplying two things together that have the same base. We can add their powers. So we get 2 to the power of x minus 4 plus 3. It's going to give us x minus 1 is less than 20. Okay, so 2 to the power of x minus 1 is less than 20. So if we think 2 times 2 is 4, times 2 is 8, times 2 is 16. So that's less than 20. If we went one more, so 2 to the power of 4 is equal to 16. 2 to the power of 5 would therefore be 32, which is too high. So we want to use the 4. So x minus 1, we want less than 20, so it has to be less than or equal to 4. Or you could write x minus 1 has to be less than 5. Either of those is fine. If you're solving this way, you get x is less than or equal to 5. If you're solving this, you get x is less than 6. They both mean the same thing because we're only dealing with whole numbers at level 1. Okay, so whichever you prefer will be fine for that question. So for the marking of this one, if you can rewrite 8 as 2 to the power of 3, you've achieved. Or if you divide 20 by 8 and simplify the right-hand side to either 5 over 2 or 2.5, then that's achieved. If you can write the right-hand side in index form, Okay, so you sort of like 2 to the power of 4 plus 4 would be the same as 20, so that's what they mean by writing the right-hand side in index form. Combining the indices on the left-hand side to their simplest form, so getting your 2 to the power of x minus 1, or consistently identifying an appropriate power of 2. So you might write x is less than 5 down here, for example, or x is equal to 5. If you do any one of those things, that's achieved. For merit, you need to do 3 of those things. So, for example, getting this is 2 to the power of 3, simplifying this, and maybe writing x equals 5. You can merit. For excellence, you get the correct solution. Okay. So the marking schedule says, guess and check following at least one correct algebraic procedure leading to a correct answer can be awarded an excellence grade. So you need one correct algebraic procedure shown in your working, and the correct answer will be enough evidence to get excellence for that particular grade. Okay, so you might write 2 to the power of 3 times 2 to the power of x minus 4 is less than 20, and then get your x is less than 5. You might write this is less than 20 and get through to x is less than or equal to 5. That would be enough algebraic working to get the excellence grade for that question. Another one from 2018. So for what values of x will 5 times 5 to the power of 3x equal 5 to the power of negative 2x squared? Okay, so we can see that we've already got 5 as the base for all of those terms, so we don't need to rewrite them. But you might want to recognize that this is 5 to the power of 1. Okay, and the reason that we want to recognize that is because when we simplify this, we want to make sure that we are adding our 1 to our 3x. So this left-hand side will simplify to 5 to the power of 3x plus 1 is equal to 5 to the negative 2x squared. Okay, and then we've got our bases the same, so it stands to reason that 3x plus 1 has to be the same as negative 2x squared. Recognize that we've got a quadratic because the highest power of x is 2, so bringing our negative 2x squared to the left-hand side, we get positive 2x squared plus 3x plus 1 is equal to 0. Factorizing, bringing our equals 0 down, 1, and it's positive 1 and positive 3, so it must be positive 1 and positive 1. So two solutions, x is negative a half from this factor being equal to 0, or x is negative 1 from this factor being equal to 0. Two solutions, both negative. For achieved, you simplify your indices on the left-hand side. Okay, so you get 5 to the power of 5. You consistently generate a quadratic expression from powers of 5 that contain 3 terms when simplified. Okay, so something happens, you might not get plus 1, maybe you get some other number somehow, so you get a quadratic, but it's not quite this quadratic. Okay, so that will give you achieved. For merit, or you consistently calculate correct values of x from a quadratic equation. Okay, so you have a quadratic equation and you consistently solve that. Any of those 3 things will give you achieved. For merit, you need to do 2 or more of those things. And for excellence, you get all the way through to your 2 solutions. Okay, and this is the last question. So from the 2017 paper, solve 9 times 3 to the power of x minus 4 is greater than 87 when x is a whole number. So again, probably starting to look a little bit familiar now. We've got this 9 times 3 to the power of x minus 4. We could divide through by 9 if you wanted to, but again, it doesn't divide quite as nicely. So a tidier way would be to write this 9 as 3 to the power of something. And 3 squared is 9. So we can rewrite that. And everything else stays the same. Adding our powers together because we're multiplying 2 things with the same base. So 3 to the power of x minus 4 plus 2. It's going to be x minus 2, has to be bigger than 87. Okay, so we know from before that 3 to the power of 4 is equal to 81. If we didn't already know that, then you could easily work that out. and 3 to the power of 5 is equal to 81 times 3, which is clearly greater than 87. Okay, so we know that we're really interested, because we want greater than 87, our x minus 2 has to be greater than 4, or our x minus 2 has to be greater than or equal to 5. Okay, so if we're solving this, you only need to do one of these, by the way. I'm just showing you, some people have a preference which one they do. You only need to do one. So if we have this, then x has to be greater than 6. Or if you've written this expression, x has to be greater than or equal to 7. They both mean the same thing because we're only dealing with whole numbers. Okay. So again, for achieved, you can do one of the following. You can express in index form your indices on the left-hand side and combine them. So 3 to the power of x minus 2. You can equate your indices that you get consistently from your equations. You can guess and check getting a correct answer with no algebraic working, and you can get achieved for that as long as you haven't used guess and check in any other questions in the paper. Or you can do a correct division by 9. So dividing 87 by 9 will give you 9 and 6 over 9. Or you might write it as greater than or equal to 10, because we're dealing with whole numbers, and that will give you achieved. For merit, you need to do 2 of those things. And for excellence, you get your correct solution showing algebraic working. Okay, so it's really important that you have some of these steps written down so that we can see you're using your algebra to solve questions. Well, that's the last practice question that I have for you today. So tomorrow is Thursday. So at 5:30, I'll go through some questions that people have sent through. So if you come across an old exam question or something that you're just a little bit stuck on, email it through to me. My email address is up here, or message it through to me on the Facebook page, and I will go through that tomorrow for you. Otherwise, if you look at my schedule on Monday, I'll be looking at substitution and rearranging expressions and formula. On Wednesday, we're going to start looking at solving simultaneous equations. There's 2 methods for doing this, so I've split it into 2 separate sessions so that we don't have too much going on at once. So next Wednesday, I'll look at substitution, and then the following Monday, I'm going to be looking at elimination. And then on Wednesday, the 9th of September, the last lesson, we're looking at problem-solving style questions and just any other sort of questions that haven't come into some of the other categories but might pop up in some exams. So that's what we're looking at. So hopefully this was really helpful. I know some people get a little bit nervous with exponential equations. I don't know if that's because they are a little bit less familiar with them. You might not have had a lot of experience with exponential equations in the past, so it might be a little bit new. Persevere, keep trying, and as you practice them, you'll get a feel for what numbers are going to work. We do sort of use a little bit of trial and error to find those powers, but we are using those algebraic skills when we are solving some of the equations that fall out when we work through these questions. Okay, so thanks for watching. As usual, if you are finding these really useful, please share them with friends, classmates, and make sure you like the page, follow the page, subscribe to YouTube. All of those things will be awesome. Hopefully I will have some questions. Well, I have some questions to go through tomorrow, but if you do come across anything before 5:30 tomorrow, email it through. Otherwise, hope to see you on Monday. Great.